Let's now see examples of restrictions of functions. In particular, we are going to see in detail a very important example that will be very useful later on. The example is no more, no less than our famous function x squared, which maps reals into positive reals. Every x is mapped into f of x, which is an abbreviation for x squared. So the function f establishes connections between this set and this set. Okay? Now, what our goal now is to choose subsets of this thing, and well, we have functions then. We want to construct functions, new functions, that agree with f on those subsets. For example, consider first let's see the picture. Before I'm going to write the thing, let us make a picture of this function. Because it is a parabola, like this. This is x, living on the horizontal axis. This is f of x. When this is 1, our function is 1. Okay? So 1 squared is 1. And so this is the real line, so the domain of the thing. And so let's choose subsets of this thing. So let me choose 2 subsets. Everything that goes from minus infinity up to 0, excluding the 0, and then another subset that goes from 0 up to plus infinity. Okay? So we have this set here, the negatives and the positives. And let's define 2 functions. So f, let me write first g. G maps the first half, so the negative reals, into R, okay? And every x is g of x, which agrees now with f of x on those values. So this thing is x squared. Is it okay? So this is the first part. The second one, let's call it h, it's positive reals to positive reals. This is also positive and negative and 0. And here maps every x into h of x, which now again agrees with f of x on this domain. So this thing is x squared. Okay? Now, the new idea that we introduced in previous video was the fact that let's give a special symbol to this to remind us where this thing comes from. Or in other words, this thing compared with this, well, in going from here to here, we just restricted f to the subset of the negatives. And so let's call this, let's give it r, negative, and this would be f r positive or 0. Okay? Notice this. I'm including here the domain of the function, but this is quite cumbersome to use this notation. So I'm going to use something more easy to use, and instead of this symbol, let me choose this reminder, less. So f less means less than 0, excluding the 0. And here, let's introduce the symbol greater or equal than 0. Okay? So the less function shows up here. The less function here, the greater or equal function. So the f greater. So this is just notation for the idea of restriction, because this function essentially describes this f. Let me draw it. This f here, open. On the other end, this thing here describes this thing, closed here, and then the blue one, right? Can you see? So the two f's describe this function. So essentially, you just partitioned the original function into pieces. Okay? Now, these are just an example of functions or of restrictions of f that we can generate. However, you notice that we can generate as many restrictions as we like. I'm going to give just one more example. We start again with f. And why not? Why not do this? Restrict something like this. And then, for example, closed like this, then open. And here you can include this part, go like this, then open, include this value, and then and so on. You see? Now you have 1, 2, 3, and 4. 4 restrictions. So it's F restricted to this piece of the horizontal line, the subset of R here, or to this piece, or this piece, and so on. So we have give them different labels. For example, let me call this F, for example, -1, to remind us that it belongs to this set here. So -1 is just a label that I'm assigning it. Here we have, for example, F of 0. Then we have here F of 1. And then finally F of 2. Okay? I want to emphasize this idea again. Previously, we said that we write F and then as an index the set on which the original function was restricted to. But you see, that might be cumbersome. The point is not that we indicate that index in the function. So when I wrote previously f of a, the key point is that you give a new symbol to that thing that reminds us of on what subset the thing is restricted to. For example, -1, 0, 1, and 2 are quite easy because it reminds us that this is the first one, then the second one, the third one, and so on. Okay? The restriction that we have. And so, this is just notation. Notation that serves one single point to remind us of what something means. Okay? Now, let's move on.